Hi everyone, this is Grant from Dome Music Technologies, and today we're going to be looking at the ACE multiplier module. This is what they call a four quadrant multiplier, and I'll show you what that means as we go through this tutorial. What I've got here is the ACE constants module outputting steady DC voltages. There's nothing at the V-in sockets here, so you're just getting a voltage output of what's on the knob here. So they're both reading 5 volts, and if we put channel 1 into the X1 input, channel 2 into the Y1 input, we've got two outputs here. So on the voltmeter, we're reading voltage output in channel 1, which is going to the X1 input. That's at 5 volts. Channel 2 is going to Y1 input, and we're reading it here, which is 5 volts again. This channel is the X1 times Y1 output, and according to the voltmeter that's 25. So it's literally 5 times 5 volts gives you an output of 25 volts. In addition, you've got an audio socket which actually divides the X1 times Y1 value by 5, and that sort of keeps it within the kind of standard voltage modular voltage range of plus or minus 5 volts. So if you look upon voltage Y1, X1 being the input and Y1 being the amplifying module, the amplifying input, then when it goes up to 5 volts, you want 100% of the voltage going to X1 to come out at the audio output. And that's what we've got here. So if we bring this down to some other voltage level, 2 volts, then you can see that when the Y1 input is at 5 volts, the output is at 2 volts. So this is acting like an attenuator. When this voltage is at 0 volts, then you've got 0% of the input voltage, and when this is at 5 volts, then you've got 100% of the input voltage. And that counts for all input voltages going negative as well. You can also have the multiplication. Either of these inputs can also be negative. So if we take that to minus 1 volts and we set that to 4 volts, then so input 1 is 4 volts, input 2 is minus 1 volt, and the raw multiplied output is minus 4 volts. If you want to treat the Y1 input as an attenuation factor, then if we put that to minus 5 volts, then we get 100% inversion on the audio output. So that basically covers all the functionality. I suppose the eagle-eyed amongst you will have noticed that a multiplier also functions as a ring modulator and also as a VCA. So what we've got here rigged up is the two oscillators, one of which has got the triangle output going to a voltage controlled amplifier, which is in turn triggered by the envelope generator. So just all very straightforward. But what we can do is, instead of using the amplifier module, we can put the input to one of the inputs of a multiplier. There's 3 multiplier circuits within the multiplier module. If we then take the envelope generator output and put it in here, and then we take the audio output of that, and what we have is the same situation. If we were to transfer it over to the raw multiplied output, then we're going to get overload on the output and a bit of distortion. So we're well into the red there. Now, so that's showing its use as a voltage controlled amplifier, and interestingly enough, if you use the inverted output of the envelope generator, you get the same effect. So because you're multiplying a bipolar audio signal by a negative amount, then effectively it all works out to give you a bipolar amplified output. So and also you can start to get a bit crazy by feeding two oscillators into that, and then you get the classic ring modulation output. So we've got two triangle wave oscillators here, and if we look at one of these inputs on the scope here, and if we take the audio ring modulated output, and that's the waveform that we've got here, and if we increase the interval between these, then we start to get into crazy kind of waveforms. What you can also do is, instead of having two oscillators feeding into the ring modulator, you can just use different waveforms from the same oscillator. So if we do a mix of sawtooth and triangle, then we get this kind of output, which is quite an interesting harmonic sound. And what you can also do is chain up the ring modulators. So if we take the output from here and plug it into this channel and take another waveform, say rising sawtooth, I think because it's giving you so much attenuation, because it's multiplying different parts of the signal, we'll have a look at just taking the output from the raw channel and put that into the oscilloscope and the output. So to me that's less interesting than the previous waveform. But you can get some interesting wave shaping effects just by mixing the different waveform outputs. So I think that pretty much covers the ace multiplier. So, okay, I'll see you in the next one.